Let's begin. Today's July 25th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and 6 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the following 6 criteria cards. Criteria card 4, 5, 9, 14, 17, and 19. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our middle digit, our square digit, and we'll be comparing it to the number 4. So should the value of square be less than 4? Should it be equal to 4? Or should it be greater than 4? Criteria card B looks at our first digit, our triangle digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card C will look at our 3-digit solution and will let us know how many of the digits in the solution are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card D will look at our 3 digits, triangle, square, and circle, and will let us know which one is the absolute smallest. So should triangle be the smallest? Should square be the smallest? Or should circle be the smallest? Criteria card E again looks at our 3-digit solution, and the Turing Machine will let us know how many of those digits are even. Are there no evens? Is there a single even? Maybe 2 evens? Perhaps even all 3 are even. And finally, criteria card F will look at our first and second digit, triangle and square, but in this case it'll add them up and compare it to the number 6. So should the sum be less than 6? Should the sum be equal to 6? Or should the sum be greater than 6? Remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just discussed. And let's begin with an initial proposal of 314. So the first thing I want to test is criteria card B. I want to know whether that first digit is even or odd. Okay, so the Turing Machine responds that it does not agree with my proposal. Notice that I did choose an odd 3. Since it disagrees, it's letting me know that triangle should be even. So let me go ahead and put that in my notes in section B. Triangle is an even digit. And of course, since it is even, I can cross out all the odds for triangle. So crossing out 1, 3, and 5. Let's see, what else can I test? Well, I've already eliminated 1, 3, so obviously they all can't be 3. But I think in this case, let me go ahead and test criteria card F and see something about the sum of the first 2 digits. Okay, so in this case, the Turing Machine does not approve of what I have. Notice I do have a 3 for triangle and 1 for square. Its sum is 4, which is less than 6, but it's telling me it can't be that. So either the sum of triangle and square is either 6 or greater than 6. So let me go ahead and put that in my notes. That triangle plus square is either equal to 6 or greater than 6. Okay, so let's see. Well, if it is to be equal to 6, it would be they would be both even, right? in some order, 2, 4, or 4, 2. But if that were the case, well, I guess maybe all three could be even, right? I was trying to see if the sum is 6 and there were only 2 evens, then perhaps it wouldn't be 6. The other thing that I just noticed, well, I guess in criteria card D we do reference circle, even though it's just one of the choices. So I'm wondering how we're going to force circle to be something. But that may be for another discussion. All right, and what about, so equal to 6, again, it would have to be 2 evens. Greater than 6, it would, if I knew it was greater than 6, then it wouldn't be, square could not be 1, or actually 2, but again, we're not sure which one it is. Okay, so I don't think I can cross out anything because there are lots of possibilities for both equal to 6 or greater than 6. That said, it is interesting criteria card A now, because if we know something a little bit about square, we may be able to figure out what triangle might be. And I do have square 1, where if it's not less than 4, then at least we know it'd be 4 or 5. That may be a good choice as well. Yeah, let's go ahead and test criteria card A. Okay, so yes, it did fail. So then that means that square has to be either equal to 4 or greater than 4, meaning it's 5. So let's go ahead and put that in the notes in section A. That square is either equal to 4 or greater than 4, which means that it must be 5. All right, so now I can eliminate some numbers from squares. So it can't be 1, it can't be 2, and it can't be 3, but I can still technically have equal to 6. Yeah. So the only 6th possibility is 2, 4. Everything else would be greater. 2, 5 would be greater. 4, 4 would be greater. And 4, 5 would be greater. So that'd be interesting. Okay, but we are done with our 3 Turing tests for this round. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. Okay, so yeah, just to confirm, yeah, we can't cross out anything because all of the remaining possibilities for triangle and square do add up to 6 or greater. Okay, so but we still don't know which one square is, and of course we did not test how many 3s. Well, now it's a 50-50. Either it's there or it's not. So that's an interesting option. Criteria card D, we still haven't found out which is the absolute smallest. I don't know if square could ever be the smallest. Yeah, I don't think square could be the smallest. Well, yeah. So square can't be the smallest because then what would triangle be? So at least we've also reduced that to a 50-50. Yeah, square can't be the smallest. And yeah, I mean even circle could be a 1 and triangle could be a 2. So, but I think we've now established that at least square is not the smallest. and of course the number of evens. Okay, so between what we didn't test, the number of threes, the smallest, and the number of evens, and of course, we still do have A and F that we're not too sure about. What kind of proposal can we come up with? Remember, we're trying to find a unique solution, and so let's see. So I think we have already kind of established that square can't be the smallest. What if triangle is the smallest? So if triangle were 4, that would mean that we'd have 4, 5, 5. But I don't know how helpful criteria card B would be, because typically, either it's there or not. I think that would, let's see, if triangle were the smallest and it were 4, then of course there wouldn't be any 3s. So at least I think we could say that triangle, if it were the smallest, it wouldn't be 4, because we would obviously know that 3 wasn't there. But what about 2? Could triangle be 2 and the smallest? That would mean that we'd have circle be 3, 4, 5. We could have a single even or no even, but at that point, again, how would you establish circle? What could circle be if triangle were 2? There's no way to really pick. I guess you could say maybe it's 6 and there are no odds, so it could be 2, 4, 4, and that would be the only way to get 6. 2, 4, 4. But yeah, right. And if triangle were the smallest, yeah, it would be 2, 4, 4. This 2 would not fit into by the smallest triangle. What if circle's the smallest? So obviously it couldn't be 5. It couldn't be 4. But it could be 3, 2, or 1. And I guess maybe perhaps even could you make the argument that if we knew now that triangle and square equals 6, well, let's see, could we say what would be the smallest? We could say it could be triangle, but then how would you choose between 3 and 5 being odd? Perhaps it would be 2, 4, 4. Yeah, too many possibilities. So let's see, really quick. 2, 4, 6. Do we want 3 evens or 2 evens? I think we would say 2 evens, and then, but what about the smallest? Yeah, maybe triangle is the smallest. It is 6. And then we'd have to choose between 3 and 5. Okay, so I think I'm going to deduce, but we're not there yet, that triangle is the smallest. The sum is 6, and it's between 3 and 5. So let's do 2, 4, 3, and see where we get. 2, 4, 3. Okay, well, let's see. If I test the smallest, and again, I think I established that square couldn't be. Let's go ahead and test the smallest. That's criteria card D. It is not the smallest. Triangle is not the smallest, so circle must be the smallest. Again, well, let me double check. If square were 4, there'd be nothing to pick for triangle. Yeah, so it's not square, it's not triangle. So I'm going to deduce that it's circle. So let me go ahead and type that up in section D, that I'm going to deduce that circle is the smallest. The smallest digit. Alright, so if it is the smallest, I don't think it could be a 5. It can't be a 4 either. It could be a 3. So it can't be 4 and it can't be 5. Okay. And now let's test. Well, let's see. We have C and E, the number of evens and the number of odds. If I test the number of evens, this will be interesting. Let's see. Yeah, I really don't want to test F again to see what the sum is. Well, let's see. This will be interesting. If I test the number of odds, then we get to cross it out, but we still have 1 and 2. And there really isn't anything to prohibit duplicates. But again, we're looking for a unique solution. Let's see. Can we say that if there are no 3s? Yeah, I think at least we can say we can cross out no 3s. Well, no, that's not true. I was trying to see if I can make a connection between the number of 3s and even. I was thinking I could say, well, if there are no 3s, then that would mean that we have 3 evens, but that's not true. You could still have 1s and 5s. But I guess we could say that we can't have all evens. That much we can say, because we do know that if we have all the evens, we have 0 3s. That we can, I think that makes sense. So we know that we don't have 3 evens. We could still have, let's see, you have to have at least 1, right? Because triangle is even. So it's either 1 or 2, not all 3, and of course none is not true. So we're down to either 1 or 2, and I do have 2 in my proposal. If I were to test F and get the sum as 6, so somehow, again, either the 3 is there or it's not. Okay, so let's see. If there were no 3, I guess technically you could still have a 1 if there were 2 evens. So if we test 3, we either keep it or it's gone. And then we can test the number of evens. But again, and we know, oh, okay, so if we test 3 and it's gone, then we know it has to be a 1. Because again, if you knew you had 3 evens, you know there'd be 0 3s. So we know it would be a 1. And therefore you know there'd be 2 evens. And then we could test the sum to be either 6 or 8. All right, so yeah, let's go ahead and test criteria card C. Okay, so and I do have a 3, but it's telling me that that's incorrect. So that means there are no 3s. And so let me update my notes. There is no single 3-digit. And so I'm deducing that there are 2 evens. Yeah, so there are 2 evens. So let me put in E. I'm deducing, there are 2 evens. And so I'm saying that circle is 1. And now I have to figure out, is the sum 6 or 8? Because I deduce that there are 2 evens. So let me go ahead and test F again. And I don't have 6, so it is greater than. It's not equal to 6. The sum needs to be greater than. Okay, so we know then, well, actually I can't cross out anything because all of these, oh man. Okay, I think I'm going to have to test one more. I've got to test whether there are, see if my deduction for E is true, that there are 2 evens. All right. Yeah, because the 5 is still there, and there's still a lot at play for the number of evens. But if there are 2 evens, then it would be 4, 4. So let me test 4, 4, 1, and I guess I'm going to be forced. Well, yeah. Yeah, let me go ahead. Well, let's see. Let me write all the possibilities. Well, let's see. There's 2. Well, yeah, let's go ahead and type them up and just do a quick comparison. So it can't be 2, 4. We know that much. So it's either 2, 5, 1. Honestly, I don't even remember why I crossed the 2 for circle. Well, let's continue. It's either 2, 5, 1. That's the only one for 2. It could be 4, 4, 1. Or it could be 4, 5, 1. Okay. So the first and the last both have. Yeah, maybe I think I can't, because let's see, what if there were 2 odds or 1 even? That would mean that 2, 5, 1 and 4, 5, 1, I believe, would meet. Oh, you know what? I have not established what square is. Well, let's see. If it's greater than, which is both the first and the last, Yeah, I think we can deduce it's 441 because again, what do the first and last have in common? They both have square greater than 4. They also have 2 odds. No 3s. Well, I did cross it out. And they all have circles the smallest and 1 even. So I think we can cross out 251 and 451 as being ambiguous because it meets all of the criteria. Okay, so maybe my instincts were correct that there are 2 evens and it would have to be 441. So I'm going to cross out 251 and 451 as being ambiguous. Again, they both have 5. The first digit is even, no 3s, circle's the smallest, 1 even, and they both have a sum that's greater. So square is 4, so I'm deducing square is 4. Deducing square is 4. Triangle's even, no 3, circle's the smallest, 2 evens, and the sum is greater. Well, let's give it a try. Wow, I also notice I've got all X's. Okay, well, this is a moment of truth. Let's see. 441 as a solution. Okay, the deduction paid off. All right, so let's go and see what did I test. So I did deduce E, that there were 2 evens, and I got all X's. So A, B, F, and C, D, F. So let's type that up. So A, B, F, and then C, D, F. And we deduced E. Okay, so we got it in 6 questions. The Turing Machine did it in 8. This might be the first time I think that I've gone all X's. So very interesting. Okay, so, and I forgot, I neglected to type the answer choice C here in my haste to go verify the solution. So yeah, so 441, I guess again, in some sense, we deduced that square was 4, and that circle was the smallest. So there were, at least 3 deductions. Very, very interesting. I think that's a first as well. Well, what do you think of this puzzle? How did you solve it? Any insight on what I did? Was everything sound? Please add anything, your thoughts in the comments. If you liked the video, please do give it a thumbs up. And if you don't want to miss out on any videos, please do hit subscribe to be notified. Well, until next time, have a great one.